Hello everyone, welcome to SS Educare Teaching Learning channel. Thank you for all my subscribers. Those who are still watching my videos without subscribing, please subscribe and watch my videos. Your support is my strength. So with all of your support and continuous encouragement, we have completed 5 chapters of biology and we are stepping to the next subject, that is our physics. Physics, it's a subject of scientists. So many scientists kept finding out very interesting and very life-turning inventions in physics only for all of us. Thus, in this particular subject, when I am explaining about this subject, we will not be having story of the day. We will be having scientist of the day. For every video, we will be discussing about one scientist and their contribution and their early life, the message from them also. So, let's go to our channel. Scientist of the day. This scientist is called as father of physics. This scientist was born in a very poor family of farmers. This scientist, when he was born, he was a premature child. And doctors didn't have an hope that he would survive. He was brought up by his grandmother and he also didn't have friends to play with in his early childhood. He was playing with only the mechanical toys and some devices in his house. As he is a very poor student in school, in his studies, he was sent to the farming by his mother. But this scientist had very great passion and he had more interest in studies. So, he came back to study in school and he became a top student in his studies. He got educated in Cambridge University also and then there also he was the top. Though he is a top student in his studies, he started earning money by serving the high table and cleaning the table for the high paid scholars. Then, when he was started earning money, he started finding out new concepts like gravity, like nature of light, like laws of motion. By this time, you all could have guessed who the scientist is. Yes, it's our Sir Isaac Newton. He is the first scientist who discovered laws of gravity, or I can say laws of gravitation. With an apple, just an apple falling on his head, he found out laws of gravitation. That is why he is called as father of physics even now. Now, the moral from Isaac Newton's early life. Though he had very not unhappy, though he had unhappy childhood, he was successful in his studies. And he was he lost his peace in privacy. But still, or I can say that he was protected by his privacy. But still, that did not stop him being the great scientist among all others. So, once Newton said, if you have a passion and destiny towards some particular channel or some particular field, you have to immerse yourself in it. And you have to surround with the people who is also heading with the same destiny. Then you will succeed in one day. So scientist for the day is Sir Isaac Newton, who found out laws of gravity, laws of motion, nature of white light and so many concepts. Father of physics. Welcome back to the channel. As I said, we are going to start up with Chapter 1, Physics, Class 10 ICSE. The Chapter 1 is about force. What is force? Force is a push or a pull. Force is nothing but when you push an object or pull an object. So that is force. It's a vector quantity. When something is measured in terms of direction, we call it as a vector quantity. Come, let's see about force. So it's a vector quantity, it's a push or a pull, and SI unit of force is nothing but your Newton. Then CGS unit of force is dyne. Gravitational unit of force is 1 kilogram. Force is equal to, as it is gravitational unit, we are denoting it with 9.8. 9.8 is nothing but G is equal to 9.8 meter per second square. We all of us know. Likewise, gravitational unit of force is nothing but 1 kgf is equal to 9.8 Newton. Newton is the unit of force. Like if 1 gram force, this is kg force is 9.8, then 1 gram force will be 980 dynes. Next, this is about introduction of force. Next, let's begin with the very basic thing. What is an object? Object can be divided into two in terms of force. One is a rigid body and another one is a non-rigid body. What is non-rigid body? Non-rigid body is a body in which the distance between the particles are changed. The distance between the two particles are changed. Whereas for a rigid body, the distance between the pair of particles remains same. So that sort of body is called as a rigid body. Third one. What happens when force is applied on this type of rigid body? Where you have a pair of particles and their distance between them doesn't change. It remains same. So when any force is applied on such sort of rigid body, what will happen to it? Let's see. See, there are two cases for applying force. Number one, the object seems to move freely. And number two, it is pivoted at one end. Pivoted in the sense is it's fixed at one end. Let's see. If it is free to move, if the object, we are not like fixing at any point. So it's free to move, left as such like that. So it undergoes or it forms translation motion. If at all it is fixed at one point, pivoted at one point, then the object will have rotational motion. It will undergo rotation. If it is fixed at one point, the particular object will undergo clockwise or anti-clockwise rotation, which you call it as rotational motion. This is about when a force is applied for a rigid body. Then, what do you mean by moment of force? Moment, M-O-M-E-N-T, moment of force. Let me take an example. I have taken a rigid body where I am pivoting it at one corner, at one side. So this pivoted, as I said, will form or will lead to rotational motion. So this is the axis of rotation. X and Y is the axis of rotation. Yes, and I am applying force on the other side. Since I am pivoting it here, I am applying force on the other side. So what will happen? As I said, take this is an object. I am pivoting it at one end. I am applying force on this side. This side. What will happen if I keep tapping? The object will turn back. I will tell you an example. So let me take this is a rigid body. I am pivoting it at one end and in the other end I am applying force. See, I am pivoting it at this end. Suppose I am applying force. See, force. What is happening to this rigid body? It is turning towards this side. It's not undergoing rotation. It's just turning towards this side. That is what is happening here. See, this is a rigid body and we are pivoting it at one end where this is the axis of rotation. X and Y is the axis of rotation and on the other side I am applying force. So when I apply force on the other side, this particular rigid body starts turning. It doesn't rotate completely because I am applying a small amount of force. So it just turns, turning effect occurs. So the distance between this one, the force and the axis of rotation, you call it as a R. You call it by the unit R and it is your distance. Now, this turning effect, when you are applying force on a rigid body, you call it as moment of force or you call that term as torque. Torque is represented by tau, the letter tau. So, here the F is your magnitude of force. Magnitude in the sense whether you are applying small amount of force or large amount of force. The force. Then R is your distance and X and Y is the axis of rotation. Continuing with torque. Torque or tau is equal to F into R. F is here force applied and R is your perpendicular distance. SI unit of torque is Newton meter, as Newton is the unit of force and meter is the unit of distance. CGS unit is dyne centimeter. So thus 1 Newton meter is equal to 10 to the power 7 dyne centimeter. So there will be a definite 1 mark question in this SI unit, CGS unit and dyne for torque, moment of force. So please note this carefully. Next, on what factors does torque depends on? As the formula says, torque is equal to force applied and distance. It definitely depends on magnitude of force and its perpendicular distance. Let's see magnitude of force. What is magnitude of force? The amount of force applied on any object. If it is a small force, what will be the effect? If it is a large force applied on the object, what would be the effect of moment of force? Let's see. See, as I have already told you, see, assume this is a rigid body. I am applying just a small force. I am just hitting the object. What will happen? It will just move to a very less distance. Or if a very strong force or very large force is being applied, the object will turn or it will rotate. That is what is happening here. See, the small force applied on an object, it causes turning effect. If a large force is applied, it causes rotation or rotational motion. So that's the tau is directly proportional to the force applied. If the force is increased or large force, then the moment of force also increases. If the force is decreased, the moment of force or tau decreases. This is about magnitude of force. Second factor on torque depends is your perpendicular distance, which is denoted by the letter small r. See, this is a rigid body which is pivoted at one end. So don't consider this. I am applying a force near the pivoted point. If I apply the force near your pivoted point, what will happen? Definitely the object will not turn. And the same thing, assume the force is not here. So this force is applied at the other end of the pivoted point. So what will happen? It will turn. It will turn definitely. So if the force is applied far away from the pivoted point, the object will turn. If the force is applied very nearer to the pivoted point, it will not turn. Therefore, torque is also directly proportional to the perpendicular distance. Yes, this is about the factors on which torque depends on. Next, how can we change the direction of rotation of an object without changing the direction of force? We should not change the direction of force, but how can we change the rotation of an object? Let's see with an example. I am taking a two circular disc which is pivoted in the middle. This is disc A and this is disc B. For the first disc, here it is pivoted and I am applying force on this direction at this end. Yes, so what will happen? When I am applying force at this end, the object will starts rotating in this direction. So I call it as clockwise moment. Again, I'll repeat, if the force is applied on the circular disc which is pivoted at the middle from this side, then I am applying force here. Definitely see, assume this is a wheel. I am applying force on one side. What will happen? The wheel will rotate this side. So this is your clockwise moment. Clockwise moment. So the sign convention for clockwise moment is negative. Then let me take the other disc. Other disc, I am applying force in the opposite direction, that is on the other side of the disc. What will happen? I am applying force here. Obviously, the object will move this side. See, the object will rotate this side. So, this is your anti-clockwise direction. So, this is anti-clockwise moment. So, the sign convention for anti-clockwise moment is positive. According to right hand thumb's rule, assume it is here. Okay, this is your right hand thumb. I am applying force here. What will happen? The object will rotate in this way. Am I right? Yes, the object will rotate in this way. So how is the thumb pointing out? The thumb will point outwards. The thumb is pointing outwards. Yes, and same way here. So I am applying force here. So what will happen to the thumb? The thumb will be inwards here. Rotation is this side and the moment of force, whatever it is, the thumb will be inside. Yes, that is your right hand thumb rule and moment of force. So in order to change the direction of object, you have to change the direction of force also. Without changing, there is no possibility. So it should be anti-clockwise is positive and clockwise is negative. Next is, we'll see numericals on torque. Numerical number 1. A force of 50 Newton is acting at hinges. Then find the moment of force. A force is acting on this hinges. Okay. So find the moment of force. Here they did not mention the distance, r, perpendicular distance they didn't mention. So let's see the formula. Tau is equal to F into R, where F is 50 Newton and R is 0. They didn't mention. So 50 into 0. Tau is 0, which means, what does this mean? Force cannot produce torque if there is no perpendicular distance. That is your first numerical. Second numerical, take a rigid bar which is 100 centimeter and it is pivoted at one end. A force of 20 Newton is applied on the other end. What is the torque or moment of force? As we know, torque is equal to force into Newton. Force is 20 Newton and this one, the distance is 100 centimeter. 100 centimeter is nothing but 1 meter. So 20 into 1 meter, which is nothing but 20 is the force Newton and 1 meter. So torque is equal to 20 Newton meter. That's your second numerical. Next, examples of moment of force. Let's see the formula. Tau is equal to force and which is directly proportional to force and radius or your distance. Force can also be written as tau divided by your perpendicular distance. And we can also say that this force is inversely proportional to the distance. If the distance increases, force applied or force required will be very less. If the distance is very less, force applied on it will be more. That is what is inversely proportional. See, let's see examples. Example number 1. Take a spanner. So assume this is your spanner and then see the distance. It has a very long handle. The perpendicular distance is very long. If it has a very long handle, then as I said, distance, if it is more, force applied will be very less. So force required will be very, very less. Then second example is door and the handle. Let me take a door where you have hinges. From the hinges to the handle, if you see, the perpendicular distance will be more. That is why all handles will be fitted at one end of the doors. So the distance between hinges and your handle is more. If it is more, then force applied on this handle will be very less. See, perpendicular distance more, force applied will be very less. That's your second example. The third example for moment of couple is very common example, hand floor grinder. You could have seen in olden days, they were not the wet grinder or electric grinder. They used to grind their floor with the help of hand. If you see that hand floor grinder, you will have that handle at one edge, near the rim actually. So the handle is present near the rim. That is one example for, say, what are we talking about? As our perpendicular distance is more, force applied will be very less. So the example for hand floor grinder is the handle will be located at the edge of the the rim actually. Next, example 4 is potter's wheel. Potter's wheel also, if you see, the stick where the potter used to rotate it will be present on the rim only, not in the center. So as the distance from the pivoted point to the rim, the distance is, perpendicular distance is more. So therefore, no need to apply more force. That is about moment of forces example. The next important topic on which more number of numericals will be asked is your couple. What do you mean by couple? We all of us know couple means two. It can be two person, it can be two substance, or whatever meant with two, we call it as a couple. Here also, as we are dealing with force, we'll say couple is nothing but two forces. Let me see an example. Example 1. I have taken a rigid bar where I am applying a couple of forces. That is force on this side on one end and force applied on other end. Let me see, this force is 10 Newton and the force on the other end is 20 Newton. Will there be any couple? Will it be called as a couple? No, it is not called as a couple because see the magnitude of force, on one side it is 10 Newton and on the other side it is 20 Newton. If the magnitude of force is not same, then you don't call it as a couple. Second example. I have again taken a rigid bar which is pivoted in the middle and I am applying forces on both sides. See, this force on one end is 10 Newton and the force on the other end is also 10 Newton. Here I said the magnitude of force is not same, so I am not calling it as a couple. But here I am applying the same magnitude of force, 10 Newton and 10 Newton. Will this be called as a couple? No, even this is not called as a couple. Why? Because see the direction of force. The direction of force is same. For a couple, the direction of force should not be same. So this is also not called as a couple. Let me take third example. I have taken a rigid bar. I am pivoting it in the middle Then I am applying force on this direction, one at the top and one from the bottom. See, this force magnitude is 10N and the force which is applied from top, it is 10 Newton. Will this be called as a couple? No, this is also not called as a couple because both of them, the line of force is same actually. So this is also not called as a couple. Then example 4. Again I have taken a rigid bar which is pivoted in the middle and the forces, magnitudes of two forces are, see, look at the direction of force. One is this side at one end and the other force is top, from the top, and one force is from the bottom. This is 10 Newton, this is 10 Newton. So this is satisfying all the 4 examples. First example I said magnitude of force is not same. Here magnitude is same here. In the second example I said direction of force is not same. I mean it is same, it should be different. Here the direction of force is also different. Third example I said this line of force is same. And here see the line of force for this force is above and the line of force for this force is below. So it's opposite. And see the rotation also, both rotate clockwise. This force rotate clockwise due to the effect of force and this one rotates this side clockwise. So this is called as a couple. Means a couple should have force which is of equal magnitude. So the pair of forces applied should have equal magnitude. Then second one, both the forces direction should be opposite. Third rule, it should have, the line of force should also be opposite to satisfy or to be called as a couple of forces. Two equal and opposite parallel forces. They both are of course parallel force only, but they are opposite. Equal forces, equal in their magnitude, opposite in their direction, not acting along same line of force. See, this line of force is here and the line of force for this one is here. So not acting along same line of force is called as a couple of forces. Now I hope you might have understood what couple is. So if it is the forces in opposite directions, equal and opposite, the net force will obviously be 0. Both are equal in magnitude and opposite in direction. If the two forces are acting on opposite sides, the net force will be 0. These two forces produces clockwise moment. See, this is producing clockwise moment and this force is producing clockwise moment. Thus, it will cause rotation. This force turns the rigid body this side and this force will turn the rigid body this side. Assume this is the bar. Force is applied here. It turns see, automatically look at my hand, assume this is the bar. Force is applied here. This is moving this side. If this is moving this side, the one is coming this side. So clockwise, clockwise. Obviously it makes the bar rotate. So it produces rotation. Continuing with examples of rotation. The first example is open the bottle cap and again close it. If we are opening it and then closing it, it causes rotation. Open in one direction and close in other direction. It causes rotation. Second example is steering wheel. Steering wheel, see, applying force on one side and the other one will come this side. So force opposite direction will cause rotation. Then wrenches. Wrenches also, it's the same thing only. Two forces acting, one in one direction and the other one in other direction, causes rotation of the nails. So that's the examples of rotation. Then moment of couple. What do you call moment of couple? Let me take a rigid bar on which force applied on one end, which produces clockwise moment, and the force applied on the opposite direction from other end produces clockwise moment, and the distance between these two is mentioned by D. So this is called as moment of couple. So, moment of couple is also a vector quantity. It is calculated by taking only one of the force, not both the forces. Any one force is taken into consideration. So, let's see, any one of the force into couple arm. We don't call it as distance here, we call that as couple arm. The SI unit of moment of couple is Newton meter, it's the same. CGS unit is Dyne centimeter. So that's the moment of couple. So with this we are ending up our today's video. In my next video, I'll continue with equilibrium, types of equilibrium and conditions of equilibrium. If you like my videos, please click like button, share it to your friends and please don't forget to subscribe my channel. Thank you.